Section 4.4 is all about optimization. Optimization is really fun. So these are all going to be word problems which, terrify a lot of students and a lot of people in general at first. But if you shift your perspective and think of it more like a fun puzzle, I think it's a lot more enjoyable. So we're going to be studying some interesting problems. I've got 2 examples planned for you in this video. The first one is what 2 positive real numbers whose product is 50 have the smallest possible sum. So the whole idea with optimization is that we're trying to optimize something. So we're trying to find the maximum or the minimum of something given a constraint. And so your goal is typically to figure out what you're trying to optimize and what your constraints are. So for example, in this problem, we are trying to find the smallest possible sum. So our key word here of what to optimize is smallest, so that means we're going to be minimizing, and possible sum. So we're going to be adding 2 things together and we want the smallest sum. Our constraint is that the 2 positive real numbers have a product of 50. So part of setting up these problems is just identifying variables or drawing a picture. There's not a whole lot of pictures we can draw for this one, but we can identify some variables. So I'm going to let A and B be my positive real numbers. Alright. And we know that A times B has to equal 50. Okay, we're constrained by that condition, so we call that our constraint. And we're trying to find the minimum sum, so our objective function, I'm going to call it S. S is A plus B. So this guy is what we want to try to minimize. So now that we have a constraint and an objective function, typically the idea is that you solve the constraint for one of the variables, you plug that into your objective function, and then you optimize the objective function by taking the first derivative and setting the first derivative equal to 0. So let's do that. So I am going to solve this constraint for variable b. Okay, so let me go to the next page. If I solve that for b, I've got b is equal to 50 over a. Now I'm going to plug that into the objective function. So I'd have s, the sum function, is equal to a plus b, but I just said that because of our constraint, b is equal to 50 over a. And so now s is just a function of one variable, a. So now I take the derivative of s with respect to a, and I get 1 plus minus 50 over a squared. So there I use the quotient rule. I set this equal to 0. Okay, again, I'm trying to optimize. I'm looking for a max or a min, so I'm looking for a critical point here. I solve this for a, so I have 1 equals 50 over a squared. A squared equals 50, and I take the square root and get a is equal to 5 root 2. I don't need to worry about the plus or minus 5 root 2 because we're told that both a and b are positive. So here I've just found one of the real numbers, and a, that one of the real numbers, is 5 root 2. To find b, we're going to have to plug this value for a back into our constraint. So we know that a times b has to equal 50. If a is 5 root 2, and we've got 5 root 2 times b is 50. If you solve for b, it turns out that b equals the same thing as a. So b also equals 5 root 2. And so a and b now are both positive real numbers, and we have found the minimum such sum that we were asked to find. Now, I suppose one more step would be good. We probably want to guarantee that this is a minimum. So we could pull in our knowledge of the first derivative test and what the first derivative test does in order to verify that this is truly a minimum. So I'm going to just say check. Check this is a minimum. Okay, so we know that it is indeed a critical point. A equal to 5 root 2 is a critical point. Is it a minimum though, for sure? So we're checking this is a minimum. So if we look at numbers on either side of 5 root 2, and if we plug them into the first derivative here, so let's see, I'm going to pick the number 1 as a test point. Oops. So I'm going to evaluate f prime of 1. And I guess I'll pick a number on the other side of 5 root 2. So let's pick 10 to be safe. So I'll pick f double prime, or not f double prime, f prime of 10. Okay, so we plug that into our first derivative. Oops, jeez. And I actually called it s. Let me correct that. So it's s prime of 1 and s prime of 10. We're looking at our s function. S prime of 1 is going to be 1 plus minus 50 over 1. Okay, I'm looking right here. Which is minus 49. Okay, so that's a minus number. And then, so that means that to the left of 5 root 2, we have a decreasing function. And if we look to the right of 5 root 2, say at s prime of 10, well, now we would have 1 minus 50 over 10 squared, so 100. Oops. Hit the page button by accident there. I think I went too far down. Well, anyway, it's 1 minus 50 over 100, which is a half, so that's a positive number. So that means that our sum function is decreasing as we approach 5 root 2, and it's increasing after we pass 5 root 2. And that means that, indeed, this is the location of a minimum. Okay, so we've verified that the numbers we found are indeed a minimum. Okay, let's try another one. So here we have trying to find the maximum volume of a cone. So, and I actually see that I'm already starting to run up towards my maximum time for a video, so I'm going to continue this in the next video.